Okay, so we are looking at the post-lesson practice for lesson 1. And we're going to start off by looking at which of the following are one-to-one functions for each state, why or why not. So when we go through and do this, we want to kind of do two things. One, we better first make sure that it is a function. Okay, it's clearly not going to be a one-to-one function if it's not a function in general. So to do that, we are going to check to see if x's repeat, or if we have the graph, we're going to do the vertical line test to see if it's a function. If we determine that we have a function, then from there we're going to determine if it is a one-to-one function, okay? Meaning I'm going to check for repeat y's. If I have a table or if I have the graph, I'm going to do the horizontal line test. So starting off with 1a over here. Zoom in a little bit. All right. First thing, when I go through and do the vertical line test like this, I see that. All right, if we want to move this a little bit, all right, it's going to pass my vertical line test, okay? So I'll use the same line later for my horizontal line test. So let's move that down there. All right, so this is a good function. Now, to test and see if it's a one-to-one function, what we did in the lesson, all right, we use this horizontal line test to check and see. So using this same line, I'm going to run it through, and it only hits once when I run through my horizontal line. Sorry, the line's kind of sloppy, my bad. All right. So, all right, I have a good function. This is going to be yes. I'll just write it on my line. That works. Okay, and the reason is it passes the horizontal line test. Okay, so that's what HLT stands for, horizontal line test. Okay, so going to number 2, I have a table this time instead of a graph. So first thing I need to check, is this a function? And I have a problem. Remember, your input are your x values, your output are your y values. So when I go and check my inputs, I see that I have repeating x's, a 4 and a 4. The 4 goes to 7, this 4 goes to 14. This is not a function. So is this a one-to-one function? No, all right, because I have repeat x's, and that means that not only is it not a one-to-one function, this is just not a function. This is not a function. Okay? All right, awesome. So moving on to the last two. Now we got one more table and one more graph. So question C is going to be a graph. So remember, same deal. I am going to first check to see if this is a function with a vertical line test. So as I go through, all right, it only hits once for each of the vertical lines. So that part is good. Okay, I have a function now to check and see. Actually, I'm going to bring that back up. All right, if this is a one-to-one function, we're going to check the horizontal line test. So as I run the horizontal line test, I go good, good, good. But then as soon as I get here, look, my graph hits that horizontal line 3 times. So even though this is a function, this is not a one-to-one function because it fails my horizontal line test, which I'm going to use HLT to represent that. All right, and so for my last one, this table over here. All right, first thing, let's check and see if it's a function. Look at my inputs. -1, 0, 1, 2. Okay, all good, no repeats. So good to go there. Now, for a table, when we're going to check to see if it's a one-to-one function, I'm looking for repeating y's. That's what a horizontal line test is doing. So as I go through, I got -1 going to 5, 3, 4, 7. I am good to go. This is a one-to-one function. I have no repeat x's and no repeat y's. Okay, so that's kind of a review of one-to-one functions, what to look for there. We'll use that a little bit more with inverses later in the unit, okay? All right, the next section we're looking at to determine if functions are odd, even, or neither. Read that in the wrong order, whoops. So there's two kind of ways we're looking at this. We have three graphs and we have three equations. So when we're doing the graphs, there is two things we are looking for. Even functions are going to be reflected over the y-axis. So let's make a little note over here. Even, all right, reflect over y-axis. Oh, it's a little laggy, sorry about that. Okay, and then that's going to mean our odd functions. Okay, our odd functions are going to reflect over the origin. Which, quick reminder, your origin is 0, 0. So that's what we're looking for when we're looking at graphs in this unit. So looking at our very first problem, okay? Now, don't let the pi parts freak you out. All right, this is still just a graph. My origin's right here. You have an x-axis and a y-axis. That's really what t and f of t are. That's your x. This is your y. So if I want to reflect over the y-axis, I'm looking here at this line right here down the middle. And as I look at kind of this M-looking shape, all right, I see I can pick out a point that it is the same amount. All right, in this case, pi, okay, this way, and pi that way. Okay, this is reflecting over the y-axis. Okay, so since it's reflecting over the y-axis, that means that this is going to be an even function. All right, and I could have kept going with different points, some further away points like negative 2 pi and 2 pi. Okay, but I tested a couple and it looks pretty good. Now, this next one. So I talked about even and odd, so same deal. Let's just go through and check this, all right? So I'm going to erase some of this here in a second, but if I want to reflect over y-axis, all right, I have this point right here. We'll see how far away that is from y. If I really want to reflect that over the y-axis, I should have another point about right here, the same distance from that y-axis. And then do I have that here? No, I do not. So, okay, I would not say that this is an even function. So let's move on to odd, and let's see what happens there. So if I look at odd functions, all right, they're going to reflect over the origin here. Okay, now, reflecting over the origin is a little bit different, okay? So you're kind of thinking about quadrants a little bit. I'm not going to get into that too much, but if I have a point up here and I want to reflect it over this origin right here, that means I should have a point down here. And look, just by this first test point, I see there is nothing going on over here. So, as I clear this up a little bit, okay, this is not reflecting over the origin, so this is not an odd. So guess what? This is an example of neither. It is neither even nor odd. It doesn't reflect over the y-axis or the origin. So then this last one over here, as you probably could guess, okay, is going to reflect over this origin. Take a look as I measure out, and I don't have actual measurements or points here, so I'm kind of just eyeballing it. All right, as I reflect this over the origin here, look, all right, over this point 0, 0, looks good. If I do that with this one, same deal. It's reflecting, looks good. All right, and then really if I do any point on here, it's going to reflect over that origin. So this is an example of your odd functions. So that's how you test to see if you're looking at even, odd, or neither. All right, now these bottom three down here, all right, from the equations of your functions, all right, you're looking for two things. One, even functions, it's kind of nice. You are looking to see if every exponent is even, okay? Is every exponent you have even for your variables, so for your x's in this case, all right? Odd, you are looking to see if every exponent is going to be odd, okay? So as I go through this first one here, I have 6x cubed, negative 6x cubed minus x. So the thing I want us to look for here is look at our exponents. We have 3, and then reminder, if you have just an x, that is typically a 1 exponent. I have 3, and I have 1. So because they are all odd exponents here, I would say that this is an odd function. Okay? Okay, so this next one here, 2x to the fourth, okay? 2x to the fourth plus x squared minus 3, okay? Now, the minus 3 kind of changed some stuff a little bit, all right? Sometimes constants are a little bit weird, all right? But the main ones I'm looking at here are x to the fourth and x squared. Reminder, constants technically are x to the 0, but remember, x to the 0 is 1. Okay, so that's why we never have to write something with 0. Negative 3 times 1 is just negative 3, so we don't put that, all right? But I have 4 an even number, 2 an even number, all right? So this is going to be an even function. Okay? Okay, so the reason I brought up that x is 0 is kind of important for this last one here. I have 3x cubed, and then I have just x of 1. So this looks pretty similar to that first problem I did, all right? But this plus 5 and that x to the 0 kind of ruins that a little bit, all right? I kind of have a mix here, actually. They are not all odd, technically. So, all right, this one ends up being neither. And if you guys throw these into a graph and check these, okay, you're going to see you can use the same process that we did in parts A, B, and C. You can reflect it over the y-axis, or you can see if it reflects over the origin. Okay, so that's kind of a review on even, odd, or neither if you have graphs or equations. So looking at this bottom one here, all right, this is just a matching section, parent function to the graph. All right, so I'm actually going to kind of start off with some of the easy ones that I think, and then we'll kind of go to the hard ones. So some of the easy ones I think, x, all right, that's a linear function, just x to the 1. That's the one you worked with most in Algebra 1. That's going to be down here with g. Okay, that's going to be down here with g. Okay, so I think let's go to the next easiest one, x squared, okay? X squared is going to be your parabola, your U shape. Now, you got to be careful, all right? B over here and E. Okay, I'm actually going to switch up colors since our graphs are kind of blue. I should probably pop out a little bit more. Let's go back to red. Okay, so we said this one's X. All right, X squared. Now, like I said, B and E are both kind of that U shape, but you got to be really careful. Look at your points, okay? Look at your points. As I look at E down here, all right, we should kind of recognize points from our parent function that if I have just x squared and I plug in 2, 2 squared is 4. I don't go to 4 in E right here. Okay, whereas this one up here, all right, if I look at 2 and go up here, look, 2 to 1, 2, 3, 4. Whoops, I went a little too high, my bad. Get that point out of there. Okay, that one does follow that. So boom, that is our x squared. Okay, and then actually we can just keep going down the list. So x cubed, all right? There's nothing too crazy about the characteristics of x cubed. You just got to kind of recognize the shape, and that's going to be over here. If you are ever stuck and you're like, I don't really know the shape for this one, I don't know. Guys, plug in points, okay? When I plug in 1, what do I get? When I plug in 2, what do I get? And see if that matches up. Negatives can also help you out as well, all right? So that one done. X to the 4th. There is our other parabola shape. It's a little bit more narrow, a little stretched out, okay? But that's going to be a little bit wider. If I plug 2 into that, I get a much larger number. Okay? All right, now, absolute value of x. There was a trick that we looked at in our notes. Absolute value. Value begins with the letter V. So absolute value of x is going to be our very first answer right here, A. All right, so we got 3 left. I think I'm missing one. I don't know where H is. So we'll talk about H in a second, okay? Because I got square root of x, okay? Square root of x. Now, what the dead giveaway for square root of x is that, look, you have no negatives, which is why C is going to be square root of x. Okay, I can't put in a negative and get anything for square root of x. You'll get an error if you throw that in your calculator. All right, and then exponential is one that we briefly talked about in the notes, okay? An exponential function kind of looks like a ramp almost, and has something called an asymptote that we briefly covered in class, okay? Now, the last one, like I said, I don't know where my graph went. A constant, okay, so I'm just going to kind of draw it in here. Like I said, I don't know where it went. All right, a constant, let's do this in green. This is different. All right, that's your horizontal line. That's your horizontal line at C. Okay, that's your horizontal line at C. So it's still a line, but specifically a horizontal line. Remember, C is just any number. Okay, if I have f of x equals 8, that's just a horizontal line at 8. Okay, and that's a review kind of our parent functions. So, post-lesson practice, summarize, went over kind of one-to-one a little bit. We went over odd, even, or neither functions, and then matching our parent function to our graph. Sweet. Thanks for watching.